Okay. This assignment is a long assignment. It covers the idea of ANOVA and regression. And it's probably going to take like 3 hours to explain everything, but this is more like the assignment and review for the final, because your final would be probably 80% based on the idea of ANOVA and regression, which is covered in this assignment. So if we read the first question, commerce students who is about to graduate decided to survey various firms in Halle Valley to see which offered the best chance for early promotion. In approaching this, the student asked, among other things, how much time must pass after the initial hiring before a good technician can receive a promotion. Suspecting that the three might be different, he's going to compare small firm, so you have small firm, medium, and large. And he's picking 6 people here, different six, and he's looking for number of weeks till first promotion. And the question is, do Yara provide sufficient evidence at 5% to indicate difference in terms of the average week until first promotion among the 3 sizes of firms? Use classical and include supportive output. Okay. Now, we are comparing, we are comparing 3 groups. Anytime you compare 3 groups or more, we use ANOVA. So anytime you're asked to compare 3 groups or more, then that's an indication that you're going to do the question ANOVA. But there are 2 types of ANOVA. There is single ANOVA, there is double ANOVA. Single is also called one-way, also called independent ANOVA. Double is two-way or dependent ANOVA. So basically, you see you have 6 here, 6 here, 6 here. You ask yourself, do we have different groups or do we have same group? Meaning, are the 6 people selected from the small firms, are they the same 6 people selected from the medium, same selected from the large, or different people? Well, obviously they're different people because these 6 people working in small firms, these 6 people working in medium, these 6 people working in large, they're different people. We have single ANOVA. So now we realize that we have single ANOVA. So we can start the process. They want to see if the 3 groups are different. H0, HA. for single ANOVA, you say mu1, mu2 equals mu3. And here you say at least one is different. And that's standard for ANOVA. Mu's are different in H0, or at least one is, mu's are the same, or at least one is different. In English, true mean number of weeks till first promotion is not different for the three sizes of firms and here true mean number of weeks is different for the three sizes of firm. So again, we're comparing three groups, we know it's ANOVA. It's different people, we know it's single ANOVA. We're comparing to see if the groups are different. To do this, H0, you just say the mu's are the same, HA at least one is different. In English, the true mean not different, and here the true mean different. Test. The test for single ANOVA is F-test. It's MS effect over MS error. So MS effect over MS error. This is the test we use for single ANOVA. Decision rule. ANOVA is standard. Under decision rule, classical way, if your F-test more, we're going to reject H0. Now, this number you're going to compare to, you get it from the F table, but don't worry about it now, we'll talk about it later. So we'll leave this for now, we'll get back to it later. You know, after the decision rule, you do the analysis, the calculations. You can do this in Excel, but I don't want to do it in Excel because I want you to be familiar with the calculation, because she might ask you to do the calculation. Now, to do the calculation for single ANOVA, remember, there are three SS's to calculate for single ANOVA. We start with the SST. And T stands for total. It's the sum of x squared over n. So we've seen this before. So nothing really special. It's the sum of x squared minus the sum of x squared over n. So you go to the table with all those numbers. Remember, there's 3 groups, 6 in each group. You're going to add them all up, that will give you sum of x. You're going to square each number and then add them up, and that will give you sum of x squared. I did that. The sum of x squared is 23,864, and the sum of x is 640 squared, and your n 18. I'll make it capital N 18 just to indicate everyone involved. So 666 total 18. You put everything together, 1108 444. So that's your SST. The other one you need to do is SSTR, where TR stands for treatment or groups. So to do this, well, first of all, you know that you have 3 groups: small firms, you have medium firms, and you have large. So you go here, you average each one. So we're going to start with the average of small. The average for small, you add the numbers up and you divide by 30, you divide by 6. If you add them all up, that's 180. You divide by 6. The average for small is, say, you do the average for medium. Same idea. You add the numbers up. They add to 189. You divide them by 6 because we're averaging 6 numbers under each firm, and that will give you 31.5. You also average large. I'm actually going to put it here. To average large, again, you're going to add all the numbers. They add to 271. You divide them by 6 again, and that gives you 451667. And finally, you average the averages. It's called X bar bar. You average the averages. So you add the 3 averages, the 31.5 to the 30 to the 45, and you divide by 3. So you average, I'm going to write it here. This is the average of averages. So you add the 3 averages and you divide by 3. Gives you 35,5556. Once you know the average for each group, small, medium, large, and the average of averages, you're ready to find your SSTR, or sum of squares treatment. Now watch carefully what I'm going to do. I'm going to take the first average, say, I'm going to minus it from the average of averages, 35, 0.5556. I'm going to square. So I'm going to take the first average minus average of averages. I'm going to square it times 6, because this average that I'm comparing was based on 6 numbers. Plus, now I'm going to take average 2, the 31.5. I'm going to compare it to the average of averages. I'm going to square, and also times 6, because this average was also based on 6 numbers. And then we take the last one, we compare it to the average of averages, and also times 6. Now, it's not necessarily going to be 666 or the same number across. It could be different. But for this question, it happens to be the same number, so fine. So we do the calculation. After doing all the calculation, I have the answer for the SSTR. After putting all these numbers in the calculator, your SSTR is 838.1111. So we have 2, and remember, there are 3 SS's to calculate. We only have 2. The only one left is called SSE. Sometimes they call it SSW. E for error, W for within. This SSTR, sometimes they call it SSB for between, but doesn't matter. The treatment, the E, all the same. This one will be just the difference between these two. And it gives you the answer when you take the difference. 270.3333. So now we're done with the calculation, or the major part of the calculation. We know the SST, we know the SSTR, and we know the SSE. The T is 1108, the TR is 838.1111, and the E is 270.333. Now we're ready to create what's called the ANOVA table. Now, to do the ANOVA table, first column is SS, and you have to put them in this order. Treatment, E, and total. So the treatment is 838.1111. The E is 2703333, and both add to the total 4444. Then degrees of freedom. So the degrees of freedom for treatment, remember, treatment is also between, and treatment means groups. So degree of freedom, number of groups minus 1. So 3 groups minus 1, 2. For the E, big sample minus number of groups. The big sample, there are 18 people, 3 groups, 15, and the total, you add the two numbers, they add to 70. Then you do the MS. And MS is basically SS over degree of freedom. So you take the first one, and you divide it by its degrees of freedom. It gives you, when you go 838 divide by 2, this number is 419556. For this, you take the 270 and you divide it by its degrees of freedom, and that gives you 18, and we don't need the total anymore. And now you go to the F test, or the F value. And for the F value, or the F test, you're going to apply this formula, which is MS effect, which is in this case treatment, over MS error. You just divide these two. And that gives you 23.2522. This is how you calculate the F test, or how you create the ANOVA table. Now, you see the process of calculating this, it's a bit of time consuming. I think this is what she's going to do in the final exam. She's not going to ask you to do the entire calculations. She will give you this ANOVA table missing some numbers, and ask you to complete it and find the answer. So she might give you something like this, where this number is missing, degrees of freedom missing, this MS is missing, and obviously the F value, or the F test. So you know, if this one is missing, these two added gives you this. To figure out this, you just minus them. So you start minusing them, and that gives you this number. For the degree of freedom, for treatment, I know it's number of groups minus 1, 3 groups minus 1, 2. Here, I know it's big sample minus number of groups, altogether 18, minus 3, 15, and here we add them. This number is the result of dividing, but it's provided. To get this number, we divide these two, and we get this number. We don't need this. And for the F-test, we divide these two, and that gives you your 23,2522. So this is what I think she'll ask, but again, you never know. So it's better to know how the calculations are done, so be in the safe side. Okay. Now this is the number F-test that you're going to compare to this. But we don't have a number here. So now we're going to get this number. We get it from the F table. The F table gives you or needs 2 degrees of freedom. Since this is single ANOVA, there is a degree freedom going this way, and there is a degree freedom going this way. The one giving this way is the degree freedom for treatment. And the one going down is for the E. The one going down is always E, regardless if it's single or double ANOVA. But again, for single ANOVA, the 2 degrees freedom, this way treatment, 2, down 15. This is called the numerator, and this one is denominator. So you can use the F table and find 215 at 5%, and that will tell you what the number is. Or you can go to any website, just type in Google F table calculator. They will ask you for what's the degree freedom numerator, what's the denominator, what's the alpha. You put the 3 and that will give you right away what the number is. So whether you look at the table or use the internet, the number is 3.6823. This is the number you're supposed to see when you look it up. Okay. Now we are ready to make a conclusion. F-test of 23,2522 that's definitely more than the 3. So this condition is satisfied. We're going to reject H0 and conclude HA. Rejecting H0, so we have to say type 1 could be committed with risk equals alpha 5%. In English, you say We're concluding HA, so at least one is different. So we have enough evidence to show that at least one of the true mean of number of weeks is different between the three sizes of firms. So one of them is different. So all we know now by doing this that one of these three groups is different. In question B of the assignment, if appropriate, use the results in part A to determine which firm, if any, are significantly different from the other firm in the average number before the promotion. So, ANOVA is designed to tell you whether they're the same or one of them different, but it doesn't tell you which one. So now we need to do another analysis to figure out which group is in fact a different group. To do this, we're going to do what's called the LSD analysis. The LSD analysis, or formula, you'll see it in your formula sheet. It's T star MSE 1 over group 1, 1 over group 2. And since it doesn't matter which group you pick because they all have the same size, they're all 666. So they're all going to have the same LSD. To get this number, you take alpha over 2. So your alpha is 5%, you divide by 2, 0.25. And for the degree of freedom, for the LSD, you always take the degree freedom for error. This is a degree freedom is 15. You know, you go to your T table. I'm gonna go to my T table here. You can use the one provided or anything from the internet, it doesn't matter. So degree freedom 15 and 0.025 is 2.131. So this T number is 2.131. So LSD equals 2.131 MSE 18, and again it doesn't matter, both groups, all three groups are 6. So you go 2.131 square root and this number when you calculate it is 5.2231. So now we have the LSD value. To see which group is the different group, we're gonna go group small versus medium. We're gonna take the average absolute value for the difference between small and medium. The average for small was 30 and for the medium 31.5. The difference is negative 1.5, absolutely 1.5. Is this number difference more than LSD? No. So this number not more than 52231, then insignificant, no difference. It's insignificant results. So comparing 1 and 2, they're not different. Now we do the same thing, but small versus large. So average small minus average large. Average small is 30, average large is 45, difference is negative 15, absolutely 15. Is this number more than the LSD? Yes. So 15, that's definitely more. So the results are significant, groups are different. So one more comparison to do. So we did small, medium, not different. We did small, large, different. Now we do medium versus large. Average medium, average large. The average for medium is 31.5. The average for large is 45. And the difference between them absolutely is 13. Is 13 more than the LSD? Definitely. It's definitely more than this number, so again, significant results. Groups are different. So now what's the conclusion? Small, medium, not different. Small, large, different. Medium, large, different. You look at the ones that are different. Which group was the common group and the ones different? Large. So we conclude that the large is the different group. So you say based on the LSD analysis, large firms are the different group. Good. One thing before we go to the next question, remember when I told you to go to Google and say F-table calculator, and for numerator you say degree freedom 2, and degree freedom for denominator you say 15. This one is treatment, this one is error, and it's always the error. This one is treatment for single ANOVA. For double ANOVA, we'll see later, it depends. And you say what alpha is. And that will give you what the number is that you need to compare to. You can also, in the same website, some websites also give you what the p-value is for that same number. Or, to get the p-value under F, do F-table p-value calculator. That's if the question asking for p-value, obviously. So you go for F-table p-value calculator. It will probably ask you for the same thing, degree freedom, denominator, numerator, and the extra thing that will ask you, what's your F-test? The one we calculated. So Google this, find a good website for F-table p-value and for F-table calculator to get the number, the critical number. So F-table critical value calculator and F-table p-value calculator. That will help you instead of looking, or again, you can use the tables. Okay. This is it for the first question. You see, it's a bit of a long question, but the idea of single ANOVA, but it's a good question. Very similar to what you're going to see in the exam. And remember, for ANOVA, there is single ANOVA, there is double ANOVA. This question is single ANOVA. And the last two questions in your assignment are double ANOVA. Question 2, I'll do in part 2, video part 2.